thing.
Yeah, I just graded all your things, your different packet tracers and all. So welcome everyone.
The only thing I got a question on is the exam. It wasn't available.
It wasn't? Let me go check then, because and here's something: when you become an instructor, you will have to turn the assessments on, and you do that inside of the assessment center. So you go in here, and I go manage activations, and I can look for chapter 1, introduction to networks. It is on from 2/7 to 5/8. Let me make sure you were in the class when I did it. Yeah, it's on for you. So you should be able to go in the module and go down and click on the chapter exam. And then it should be available for you. Are you logged in where you could try it for me right now? Because you should have.
I'm not logged in yet. Let me get logged in. I'm going to use another PC for that.
Okay, that's no problem. Let's see, who just dropped in here? Pull my participants one out. Scotty, how are you? Welcome. Scotty, I'm recording. We're just getting started. Were you able to see the exam, Scotty, when you went in? Are you able to actually launch the chapter exam?
Yes, I did the chapter exam for chapter 1.
Okay, I just want to make sure it was available for you. John saying he wasn't seeing it. I was showing him when you do become you become an instructor and create a class, the exams are not automatically on. So if you go to the assessment center, you're going to need to actually turn exams on, and we'll go through all this when we actually have later in the class. But there's a create activations tab, and you have to activate each exam and give it a specific time frame that they're activated. What I've done for you and for this class, I make it really easy. I turn on the exams for 90 days. So exams are basically on even past when the class ends. But you can see I've turned all the chapter exams on. You've also you've got the ability to take the chapter exams. I think it's 5 times, up to 5 times, with no need for me to re-enable your attempts. So you've got you can use these for study as much as for actual assessment.
Okay.
So that's one of the things that's a little different about this class versus some maybe things you've done in the past. You do have to turn those exams on. One of the things I checked with John, I wanted to make sure the exam was turned on after he was a member of the class. The students, when you activate an exam, it only activates that exam for the students currently in the class. If you then add another student in, those activations don't apply to that student. So I always wait to activate them until the exams until I've got everyone in the class.
Okay. The quizzes are automatically activated, right?
Correct. The quizzes are automatically activated. You don't have to worry about turning those on. You actually can change when they're available, in terms of you should be able to edit here and edit when they're actually available to the students. So you see, you could give, if you wanted to give them for some reason, only give them 1 day to do it, you could do that. Just be aware, if you set this date, then it will not be available any other time. Once that date passes, the students are not able to do those quizzes outside of the available dates. It's pretty much a hard set, but by default, they're on and available, and the students can take them. So, John, were you able to check?
I'm getting there. This PC that I've got here, I'm kind of frustrated with it. It's been acting up lately.
I understand. Folks, I'm going to turn off my camera because, again, it makes the session a little bit bigger than when I have to actually do it. But everybody's seen my ugly self. Typically, I'm in Tangerine on Tuesdays, but Scotty, I was just telling John I've been in court all day for the guy who hit me when I was cycling. So, yeah, it's been a day. Yeah, I don't think I told John. I don't think I told this class, but I'm recovering from a spinal cord injury. I was hit cycling last March 25th and was actually paralyzed from the neck down. So if I happen to cancel class due to something coming up with therapy or something of that nature, please be aware I'm still in therapy trying to get everything working. But it's a process, a long process to get everything back.
Actually, it is showing up as being available. Before I was getting like a 500 error or something like that. Is that what it shows whenever it's not available?
No, if it wasn't available, it would simply just say the assessment is not currently active. Contact your instructor.
Okay, so there must have been something going on here.
Okay.
I'll have to pay attention to that. All right, thank you.
No problem. Well, good. I'm glad it was available. And Scotty, what I'm going to do today is really go through Chapter 1 extremely quickly. I'm not going to spend a lot of time on it because I believe when we go through Chapter 1, this is a chapter all of you are pretty familiar with. If you're in networking and you have any contact at all with the networking world, then this one's pretty simple for you. I did have a very interesting weekend. I got to teach the technology, digital technology merit badge for a group of Boy Scouts this weekend. And, you know, now that I think about it, I didn't use it, but I kind of wish I had shown them some of these introductory slides where I'm showing you how networks are in our daily lives, because it was a big part of what we were looking at is how has technology changed even recently. You know, we're seeing such a huge influx of technology in our daily lives. Do either one of you have an Alexa or a Google Home?
No, I don't.
Okay.
I have an Alexa.
You have an Alexa? I have an Alexa, and actually I have both, a Google Home and an Alexa. I bought the Alexa when I was in the hospital. I was in the hospital, you know, and couldn't move my hands and couldn't get out of the bed, couldn't move at all. But the neat thing was I could set it up and I could talk to it and have it do things. So, you know, we're in a world now where, you know, I've got a nephew with Duchenne muscular dystrophy, and he can't really use his hands very well, or he's in a wheelchair. Well, he can get a Google Home or an Alexa and turn lights on and off. You know, and I always teach at the same time, everything's becoming networked, but there's danger in that too, because, you know, Alexa's sitting there listening to what you're saying. Google Home's sitting there listening to what you're saying. You know, this is one thing that scares me to death is quite honestly, this little thing right here is one of the most scary things we carry around. You know, you walk in a Chipotle or you walk in a restaurant and your phone says, "Would you like to leave a review of blah?" You know, and you're like, "No, I'm good." And, you know, I got location turned on. A lot of people turn it off, and many times I turn it off too. But it's also handy to know, you know, walk into a store and it pops up and says, "Hey, did you know this is on sale?" Or did you know, especially navigating. I picked with the Boy Scouts. They would be the only ones that know how to use a map in the next 10 years. Because I had friends from Germany, and if they couldn't use their Navi, let me give it a name. They say Navi. If they can't use their phone to navigate, then they're useless. But, you know, it's kind of funny. I've also used this very phone, not this phone, but I've used a phone like it. When I got lost on the river one time, a big fog rolled in on the river, and I could not see anything. It was daylight, but I couldn't see anywhere. You know, and it was starting to get dark. So I just took my phone out, pulled up Google Maps, and I was able to navigate down the river using my phone instead of having, you know, I didn't have a GPS on my boat. So it's a handy tool, but it's an interesting time we live in terms of networks. And, you know, this whole chapter goes through about how we support the way we learn. Used to be the way Cisco had a saying, networks support the way we live, learn, and play. I left my house to come in class today at 3:30, and when I left, my 3 nephews and my niece were all upstairs playing on my Xbox One. You know, they were over at the house and using our networks and those communicating with those connected devices. So it's an amazing world we do live in, especially us. When you think about when I was growing up, there were no cell phones. I still don't know how we caught up with anybody or met anybody anywhere. I guess we had, like I said, we had those meeting points that we would all know that at this time be there. But it was a very different world than the world kids today are coming up in. So we talked about collaboration tools, WebEx, Skype, Google Docs. A lot of Google Docs stuff we're doing here in the state of North Carolina. We're doing some projects, and Google Docs are at the center of it.
We do a lot in that too in my classroom.
With Google Docs?
We do, and we use the Drive a lot too, so
yeah.
Google Drive and share
Definitely
folders.
Google Drive. I'm probably one of the only people in the world that actually pays for some Google Drive space because I started to run out of space, and so I actually buy space every month, pay like $2 to get 100 gigs or something. And then on top of that, I've got, you know, I think it's 276 gigs backed up on Carbonite. So I back up everything, all my pictures and things through Carbonite, which is a really cool service if you've never used it. And I don't get a dime for them, so I'm not advertising, but You'd be amazed the number of times I've had people come in my office and say, "Can you fix my computer? It's not working anymore." And I'm like, "Okay, but the hard drive's dead. There's nothing I can do." And I say, "You had a backup, right?" And they're like, "No, can't you get my pictures? It's got my baby's pictures on it from the first 3 years of their life." And I'm like, "So you had backups, right?" And no, they didn't have backups. And then they expect you to do some kind of miracle and resurrect the computer.
What was that, carbonite?
Yep, carbonite. Carbonite, and like I said, I don't get a dime from them, so. But it's basically $60 a year, and you load the software on your PC, and then you mark items to be backed up. So, for instance, I've got a D drive or a drive, not even a D drive, but a drive that's got all my pictures on it. I right-click on the pictures folder and say, back this up, and then everything that goes into that folder gets backed up onto the internet. And then you can also sign in and access those files from anywhere in the world. So you've got a way to access the files that are being backed up. But you can download a free trial and try it for 15 days, but it's really neat. The best part about it is how simple it is. There's no manually having to move files into Google Drive or something like that. If you mark a folder as being backed up, it gets backed up. So I actually use this for my wife's business. I have a business section too, and I back up their server so that everything is automatically backed up. So it's a pretty neat little piece of software.
Thanks.
But also very important, because as we continue to make more and more of our lives digitized, those are going to be issues that we run into. Storage is huge. I mean, our network has problems around here on our side because of just storage issues. No one ever wants to delete anything, which ends up with drive space becoming a precious commodity. And normally what we do to fix that is we just throw more drive space at it. I was talking about my niece and nephews playing on my Xbox. Well, I bought an external SSD to go on it just to have more drive space. So it's an ever ongoing problem. All right, so clients and servers. What does a client do? If I had to ask you to define a client, what would you say? So, John, how would you define the client?
It's a device that's actually interacting with a human being most of the time.
Correct. Definitely. So it's usually an endpoint. A lot of times we'll call a client an endpoint. And it's an endpoint device, and usually clients are used to access services from another device. So in a client-server environment, the client is that device which is asking for services, file print, network access, web servers, any of those. And then the server is on the opposite end would be the device that provides the service. All right. So we have clients and we have servers, and that's exactly what we have here in most networks. Now we do have, obviously, they talk a little bit about a server-based network and a peer-to-peer network. Peer-to-peer are networks that are designed to, each machine is both a client and a server. They're not very secure. They're not really designed for centralized administration, but they are less complex and are easy to set up. They're also cheaper. They're cheaper because you don't have to have a big server. We're in the process right now of installing another Dell Vertex server, and those servers run fully populated around $50,000 a piece. So even a small end Dell server is going to run you $4,000 to $5,000 this day and age, which is still better than it used to be, because it used to be every server you would buy would be $8,000 to $12,000. So in order to have a network, I always tell people there are a couple things you need. You need something to share, which they don't really talk about here. You need a media or medium, all right, and then you need a protocol. Now, they divide it into devices, media, and services. So something to share would technically be those services. So what are you going to share among the many people on your network? It could be file folder access. It could be your storage. It could be web servers. It could be a multitude of things. I say media or medium, and they put media down here, but I disagree with that. I think it should be media or medium. Why?
it should be media or medium? You think it should
Media
be
or medium, yes. Why is that?
Because when you're saying medium, you're talking about how it connects using like Ethernet or fiber or, right?
Right, so media would be any of our normal, copper, fiber type of connection. But medium, a great deal of our things today connect via wireless, don't they?
Yes, they do.
So I disagree a little bit with this slide where they talk about media and just media in general, because it's, yes, there is media. There's a great deal of wireless connectivity going on today. And that's one of the things driving Meraki, which is one of Cisco's divisions. And if you get my emails from the instructor side, you may not be getting them yet because, again, you're in the first class, so you're not in my list of instructors. But there's been a Meraki seminar series that's been going on through the Cisco Networking Academy. It's been very interesting. Meraki is a section of Cisco that deals with cloud-based network management technologies, and they've got wireless that's managed through the cloud. Very neat. So again, an end device, by the way, John, end device, that's what a client would be. It's either source or destination of a message transmitted over the network. And then the intermediary devices would be those devices in between end devices, and that's our network switches, our routers, our firewalls, wireless routers, all those networking devices that are available. We're going to talk about all those in this particular course, or most of them. Here's our media, obviously, metal wires, copper. Layer 1 on the OSI model, we'll talk about the OSI model. Fiber optic cables, and then we do have wireless being shown here, and they use that, they say network media, but like I said, I wish they'd just say network medium instead, but syntax. All right, some of the things about wireless are wired. How long do you need to be able to pull the cable, or how long you need the signal to be effective? What environment would be installed? My dad worked in an aluminum mill, and they had computer devices, and they had to run fiber to them because in an aluminum smelting mill, they have these huge pots that run on electricity to melt and smelt the aluminum. Well, that created a magnetic field that was amazing. You could actually, if you had a credit card in your wallet, it would actually wipe the credit card, so you couldn't take those into the pot area with you. So that would be a definite reason why you need something like a fiber optic cable versus a copper cable. That's neat. I didn't know you could actually pull that around like that. Learn something new every day. Here's our representations that are pretty much standard in the industry that we're going to use. You'll notice these. I think both of you have done the labs for Chapter 1 and most of Chapter 2. These are the exact same ones used inside a packet tracer, so you'll see them again and again. Here's a NIC. You'll learn that's a layer 2 device, or a data link layer device that has a physical address on it, known as a MAC address. Sorry. Here's our topology diagrams of physical topology. Now, one of the things that is interesting, and we'll go over this many more times throughout this course and others, but networks do have a physical topology and then a logical topology. This used to make a really big difference back when we had true Ethernet using RG58, so actually using coaxial cable, where you would have a literal bus network with terminators and only 10. And then that would be a physical bus and a logical bus. This day and age, typically we'll have physical topology that may be a star or star mesh, star wired mesh. But the logical topology is different because it's based upon how the network is broken up in terms of its IP addressing scheme. You also hear sometimes the logical device or logical topology and physical topology, physical being the way devices are physically hooked together with cabling, and logical being the way the data actually moves through the network. The biggest example of that where it really was majorly different that I've dealt with was token ring. And in token ring, you had a little thing called a multi-station access unit, and that device looked like a switch and had machines off of it in just a wired configuration. And then it actually had the data moving in a ring. because of the way it was wired internally and through the cables going out to the PC. So that's one of the biggest differences we've seen, or I've worked with in my days in networking. And by the way, Token Ring was horrific to work with. Now, what types of LANs are there? Well, there are LANs, local area networks, limited geographical areas, the way you remember that, local and limited. You've got wide area networks. Those have no geographical limitations. Then you have MANs, which are metropolitan, and that's within a single city. There is a thing called a campus area network, which they don't show here, but that's a campus area network. A lot of times we just kind of intermix the word WAN with that instead of using campus area network. They do talk about a wireless LAN, and they talk about storage area networks, and those are networks that are in the back end on the data centers to provide super fast access to your storage, typically on the back end of virtualized servers. They give you a separate storage network that the servers will talk to the storage on that back end. The other one I like to mention that's I think very interesting, especially for folks, is to talk to them about a PAN, a personal area network. That would be a network where, let's say, give you a great example. On my bicycle, I've got, well, I've had the one I hit on. I had a GPS, and the GPS connected to my phone. And so my phone was in my back pocket, and it tracked where I was at all times, and my wife could actually just pull up a web page and see where I was at and know where I was at any time. If a text would come in, it would pop up on my little GPS and tell me. Now, I couldn't respond to it, but I could at least see it. So it was kind of a personal area network, so it's a network just around your, in a small area around your body. Same kind of thing with one of these Fitbits or with any type of device that talks to your phone. So those are good to kind of tell your students about. And I believe it's going to kind of blow through internet, extranet, talk a little bit about, do we need to talk a little bit any about cable versus DSL? We all good there? Okay, so that was our first packet trace.
I'm good on that. I was thinking that my speaker may be interfering, so I was trying to.
That's fine. That's fine. If you need to mute, that's fine. Just if you have a question, you can unmute.
Okay.
So, converging network, how we've now got everything running on one, and that's just the truth, folks. We've got everything runs over TCP/IP. We've got you know, voice over IP. We've got now we've got video over IP. So we've got our security cameras going over IP. Everything's going over IP, and so that's pretty much the way things work. Now, this is a little bit on fault tolerance, you know, how to make sure that you've got redundant connections. I always teach my students the following, that is, I can make you the most fault tolerant, redundant network in the world, but you'll never be able to afford it. So if you want 99.999% uptime, you're going to end up paying a lot more for it. So fault tolerance is always a balance between budget and the need to have fault tolerance. And depending on your environment, your fault tolerance may be a different level than others. You know, your business may be able to handle being down for a day or so. I have a friend who works for a bank, and basically for every minute their ATMs are down, they lose over $1 million. So that's something that can't be down. It's not even an option. Scalability is how well can you add new devices or new buildings or new companies into your environment. Scalability, network that is scalable can be easily added to and easily expanded. QoS, very important when we get into voice over IP, because it's the voice going over the network is much more important than somebody trying to check their latest eBay or Amazon order. So that's one of the things where you have to mark your voice over IP traffic as high priority. That way you will be able to ensure quality for those conversations. You don't want someone, you know, it's okay if a couple packets in an order for Amazon arrive out of order and need to be retransmitted. It is not okay if part of a voice message, as someone is speaking, has to be retransmitted, because it would make no sense. It would be gobbledygook, to use a technical term. And then security is a huge deal, period. I mean, it's just out there. Confidentiality, integrity, and availability are three of the big things we try to have. So keep the data where only those who should see it can see it. Make sure the data is not changed in transit, and make sure the data is available to anybody who's trying to access it. And that's the security triangle here that you will learn in Security Plus if you've ever done Security Plus. So couple other things here. Bring your own device, online collaboration. So everyone's bringing their phone to school or to work or whatever, and they're connecting it to the network. How do you control that? How do you secure that? How do you ensure company data is not on the phone? One of the things I I will not check my email on my personal phone. I will not set that up even though I'm available to do it, because when I go to set it up, they ask, are you willing to allow your college to delete your phone if they find out that there is a security breach or something to that nature? And you know what? That's fine, but I don't trust the fact that, you know, they're not a target. So someone could remotely access that and enable it and then delete all the data on everyone's phone who's connected. So call me a little paranoid, but they also don't pay for my phone. So if I worked at a company that paid for my phone, it'd be different. Of course, I'd have my email on that phone. Online collaboration, well, that one's easy, folks. We're sitting here and we're all in different places across the United States having a class, which is actually pretty amazing. We never would have thought that back 20 years ago, 30 years ago, when we were in school or when I was in school and getting old, that we would be able to do this type of thing over the internet. Video communication. Again, we've got that. Hey, here I am. You can see my Chewbacca behind me. So it's pretty amazing that we have the ability to do this type of thing and to talk around the world. You know, I've got a friend in Germany. It's coming to Gen Con this year, and we're talking about all the different stuff we need to get done for that. So it's an amazing world we live in, and it's kind of funny how quickly. I definitely know I'm getting on and say kids today, but it is kind of amazing today when kids don't really think about how powerful their phones are and what all they can do. Clouds, big thing. Obviously, everything's moving out to the cloud. We've got our power going out to the cloud in terms of our compute power. Our storage is out there. I showed you Carbonite. That's online cloud storage. There's all types of clouds, everything from public to custom-built clouds. People are building their own internal clouds and having this cloud computing out there. Technology trends, all of the security systems now where you can lock and unlock your house remotely, where you can see things remotely. That's an interesting trend. It's also a very interesting security hole. Recently, one of the big attacks on the East Coast DNS infrastructure, the DNS or dynamic DNS infrastructure, was done by Internet of Things devices. So a lot of these little cameras in the houses, all different types of items that were not secured correctly were used to launch a denial of service attack, which took down part of the East Coast DNS for a while. This is one I used to dismiss. Honestly, I said, oh, nobody uses power line networking. Come on, what are you talking about? Then I had somebody who lived in New York City in one of my classes, and they said, well, let me explain something to you. If you live in New York City and you live in an apartment, you cannot use wireless because there's so many other wireless devices and people around you that many times we use these power line networking devices to give us wired network connections between our different devices. And I never thought about it because, of course, I live out in the country. You know, my nearest neighbor's 800, 900 feet away, maybe more. So it's, you know, it's something I never thought about, but it is something that's being used in that environment. So that was an eye-opener for me. Either one of you used any of these power line networking devices?
I haven't.
I haven't either. Like I said, I live in a remote enough area. I don't have to worry about wireless interference. I did actually have, when I first switched to 5 gigahertz, I had my phones interfere with my wireless networking. It was kind of funny. I was on the internet on my laptop, and all of a sudden it dropped off. And I'm like, what in the world? And like 3 minutes, I went downstairs, rebooted the router, everything, come back up, got on it, everything was good. Got back on, working fine, and then dropped off. I suddenly could hear my wife talking downstairs, and I'm like, are you on the phone? She's like, yeah. I said, hang up. And she's like, why? And I said, just do it. And I said, I'm testing something. And she did, and my internet came right back up. So I found out the phones and the wireless router were using the same channel. So I just went in and changed the channel on the wireless router, and that was that. Pretty easy. This is something actually that it's funny. If you look up Google Fiber, Google is now looking at going to a more wireless broadband type setup instead of putting in actual fiber, which I thought was very interesting. They're halting some of their fiber implementation in anticipation of this being the way to go. Our security threats are there, obviously, internal, external. Some solutions are there's so many. I mean, there's so many different solutions out there. But you know, we teach the basics in this course. Make sure antivirus is up to date. Make sure you've got your machines patched. Make sure you don't open things you shouldn't open. It's pretty simple. Then they go in and do a little bit of marketing. So, you know, there's the Cisco architecture. Here's how we do it. Okay, buy all our stuff, which you can't blame them for doing that a little bit in here. And then we talk a little bit about the CCENT. Do either one of you have your CCNA or CCENT? Have you? You're just getting started, so I figure you don't.
I have my CCENT, but it expired about 2 years ago.
Okay, okay. Well, the CCENT is still there. You can do the 2-test option or the 1-test option. I would suggest for both of you is after you take this course and Routing Switching Essentials this summer, which, by the way, I'll have the probably tomorrow or Thursday, I will have the summer schedule sent out to everybody, and I'll send it out to everyone in class. But once you finish those 2 courses, Introduction and Routing Switching Essentials, I strongly suggest you go and take your CCENT. And then once you finish scaling and connecting, we can get you into your the second part of the CCENT, and you'll have your full CCNA.
Okay. I plan to do that. I just got my Network Plus last month.
Okay, good.
So, yeah.
And this, you know, the entry level is CCENT, then CCNA. Now, they do have some CCNA kind of specialties like CCNA Security. We do teach that class here, too. CCNA Data Center, we don't teach that one. That's one of the ones I'm halfway to and still working on. CCNP, we do teach some of those classes. I'm a CCNP. Then we have CCIE, which we don't currently have anybody on staff to CCIE. Maybe, we'll see. I'm going to go.
Those are fully online?
Yes.
Oh, great.
Yep.
I might be interested in some of those.
Okay, good, good. Yeah, well, I'm going to offer, looks like I'm probably going to do a CCNA switch class starting in the summer. We'll see. Depends on how many classes I get scheduled for, what I can do. All right, let's talk a little bit about anything else in Chapter 1 you need to discuss or want to discuss. You good? Everybody okay with the format of the class as far as doing the packet tracers? Now, I know, Scotty, you put in one of the packet tracers you completed did have a completion item, so you gave me a screenshot. Thank you very much for that. Several of these first packet tracers don't have anything that you can really upload in terms of showing a check results. So just upload the PKA on that. On the labs, both of you are doing a good job, and everyone's doing a good job of answering just the lab questions. So in Chapter 1, those lab questions would be just going in and filling out the Word documents that are there. John's lost his mic. Okay.
I haven't used NetLab yet, so I'm kind of nervous about that, but I'm sure it's probably user-friendly.
Oh, yeah, just jump in there. I mean, it's not anything crazy hard to do. I'm going to come over here. I'm going to log in over here just because it's not I don't trust you. I just don't trust y'all. So I'm just kidding. I don't trust anybody. So here's NetLabs. Your class is should be ITC Intro SP17. Okay. And I'm going to do, typically you just go down and schedule yourself. And I'm going to actually schedule an individual learner. I'm going to schedule, I should have my student account here. I'm going to schedule my student account. And here are all the labs. So you've got right now there are 5 one labs, but they should be the exact same. But you can click here, and then you can schedule one of the 5 pods. And again, just pick your time. I'm actually going to do a schedule so I can actually jump in. Now, you need to give it about 8 to 10 minutes to boot, maybe a little bit longer because this is actual gear booting. So be aware of that. It's not instantaneous. This is not packet tracer. This is 3 routers and 3 switches or however many is being used for this network. Whatever's being used for this network is actually being booted in my closet right now. So I can go back there and hear everything powering up. So we'll come back to it in a second. But that really is all there is to it, Scotty. And then you go through and do the lab. if the equipment pod is still starting, you'll get this message, and you can just go back, or you can sit there and wait, either one. So it's a pretty simple system. I think as long as you've got Java installed, you'll be fine. Everything works pretty good. Knock on wood.
I'm still having issues with WebEx, so I'm not sure.
The WebEx, they keep updating it, so I don't know, and that may be why John lost his mic, but they keep doing updates to it, so it's, you know, it's, yeah.
So if I'm late getting in, I'm struggling to get in, but
Okay.
I'll try to work on it sooner. I didn't think
That's
it would take
fine.
me 15 minutes this time.
Well, today I had a little trouble getting in, honestly. I tried to get in right at 4, and it took me a few minutes to get everything going myself, so it can be a struggle sometimes. Let's talk a little bit about Chapter 2. I'm not going to get all of Chapter 2 today, but I do want to get started into it and talk a little bit about it. The big thing I want you to realize is that the Cisco device, a router, is simply just a specialized computer. That's all it is. It has a CPU, it has RAM, it has storage, it has an operating system. Okay. The operating system used on a Cisco router is the iOS, okay, the Internet Working Operating System. And with an iOS, you obviously have, or with any device, any computer, you have hardware. So you have the physical hardware itself. If you open up a Cisco router, I can point to the CPU, I can point to the flash, I can point to the RAM, power supplies, all of those things. Same thing as a computer. The difference is that device is what has ASICs in it, or a router has ASICs, application-specific integrated circuits. They're designed to do one thing and one thing only: take packets apart, look at where they're supposed to go, and then route them and put them back to where they need to go. You have, in the iOS, you have a kernel that interacts between the software shell and the hardware itself. Okay? And then finally, you got the shell, which is the user interface, which for us is going to be a GUI, or it could be, not a GUI, excuse me, a command line interface for us. It can be a CLI we're going to use. Now, there are GUIs for Cisco devices, but for the most part, we don't use them in this course. We learn how to use the actual command line interface. So here's a CLI. This is Linux. By the way, Cisco iOS is a derivative Linux. So if you know Linux commands, most Linux commands work in Cisco iOS, which is kind of nice. This is a graphical user interface. This is really pretty basic. This is what a CLI is. This is what a graphical. You'd be amazed, though. I had to tell the scouts how to open the command prompt, and none of them knew what a command line interface was. It was pretty interesting. So what's the purpose of an iOS or an OS at all? Well, it's to run the device. It's to provide the services the device wants to use. We're going to focus in this class on iOS release 15.x. If you bump into older devices, some of the commands we use in this course may not work. So be aware of that. If you're looking at old books, or again, you come across any old device, most of the commands will work. Some of them won't. So be aware of that. We're looking at all our commands through the eye of iOS 15.x. How do we access a Cisco router? Well, there's a couple ways. One is we can literally plug into the console. Now, on the back of a Cisco router, now I need to go get one, but we don't have time because we're running short on time. But on the back of a Cisco router, John, you can type in the chat, but Scotty, do y'all have Cisco devices at your school?
Yes, we do.
So the console port on the back is typically marked with it's on older devices as an RJ45 connection. It's got a blue, the name blue, or console in blue. It's a nasty Carolina blue. Sorry, but I went to NC State, so I had to say that. The newer devices, there are some devices today that have both a small micro USB connection, not micro, it's micro, yes, micro USB, and then also an RJ45. Now, those do not have two console ports. Only one of those two can be used at a time. So you're either going to use the USB connection or you're going to use the RJ45 connection. But the console is an out-of-band management where you walk up, take a device, a machine, a PC, and you take a terminal emulator and you plug in the console and you work on it out of band. All right. most initial configuration will take place on a console connection out of band on the router. Another option is secure shells. We can set up where we can come across the internet and connect remotely, or across any network, not just the internet, but across the network to connect remotely using secured shell, which encrypts the information going between the two devices. You also have the option of telnet, which is of the devil. Okay, try never to use telnet, because when you telnet, all your information is sent back and forth in clear text. Okay, well, John, if you do get a chance to go over and look at the devices, go look at them and just look for that console port, and you'll see that console port. Now, something not mentioned here you're going to see too. There's a port on the back of routers typically called an auxiliary port, or auxiliary port, AUX. That port has traditionally been set up for connecting a modem to, so you can reverse telnet into it via modem. Little secret, if you can't get in via the console port for some reason, plug into the auxiliary port. If they haven't set passwords on the auxiliary port, sometimes you can bypass the security that's been set on the console port by using the auxiliary port. So that's a little trick that sometimes you can get into a router and work on it. So here we go, terminal emulation programs. There's PuTTY, Super PuTTY, TerraTerm, Secure CRT, OSX has OSX terminal. Used to be we all used HyperTerminal because it was built into Windows, but it is not built in anymore. I personally use PuTTY, so I can pull up, you know, for me on here with PuTTY. I don't know why it's taking forever for PuTTY to open. Let me try it from here. There it goes. So I've got, I can SSH or Telnet, but I can also do a console connection. If I was doing a console connection, I would be able to actually set the console settings, and I don't have a console cable connected, so I don't even have it really connected on this particular machine. But you would have the ability to connect with a console connection. Now, the big thing here is we do have some settings we need to do. So here's serial. I don't have a serial port set up on my machine right now, so it's not showing it. But you've got to set some things. One is you need to have 8N1. So you need to set, that's a different thing. You need to set the number of data bits to 8, stop bits 1, notes 8N1. Golly, I'm having brain freeze here. I just did it on, but it's 8N1, and always turn off hardware flow control on USB devices. So let me pull up. Let me pull up. Now, like I said, it's hard for me to show this to you since I don't have a console port on this machine, but I can show you this way. And yes, this is simulation, so apologize for that. But I got a PC. I'm going here and I'm going to grab a router. It's at 2911. Then we'll go to the cables. I'm going to connect from the RS-232, which will be a serial, into the console. Notice it does say auxiliary. Then I can open up the PC and I can go to my terminal emulation. And I'm going to do 9600 baud, 8 data bits, no parity, 1 stop bit, and flow control none. Now, on many devices, hardware set as flow control. When you are doing this on a real PC with PuTTY, make sure you turn that to none, especially if you've got a USB to serial converter, which most of the time you're going to have today because PCs don't have serial connections on them. And then now I'm connected to this fake router, this simulated router. Now I want to show you this. I can do a show version, and you will see that this router being simulated uses the 2900 C2900 Universal K9 image version 15.1 M4. So this is a 15.x iOS version that's being simulated inside a packet tracer. It's actually using this image right here. So that's an interesting thing to show you, kind of the process of connecting a console to a device inside on a router without No, again, I can go get it one and show it to you and show you plugging in the cable, but it's exactly the same thing. The big thing here again is most PCs don't have serial ports on them today, so be aware that you're going to have a USB to serial adapter. Here's one. You got trip lights. You know, you can buy cheap ones, but be careful going with super cheap ones because sometimes they give you trouble. Of course, I've used some of these StarTech ones before, and they work fine too. But be aware that's an issue. Now, this is the new. This is something new here that Cisco's come out with. This is a USB Cisco console USB to RJ45, and they've also got USB to a to the new micro cable. So that's what's available there. All right. So modes of operations. I'm actually going to stop right here because we're at the end of an hour or close to it, and I've got another class at 5. But I do want you to, if you haven't done so already, read through Chapter 2. I know, Scotty, I think you've turned in several of Chapter 2. You hadn't done the hands-on lab in Chapter 2 yet.
No, I hadn't done it yet.
Okay. So let's all right, that's no problem. And I hadn't put dates on yet. I will put dates on tomorrow or the next day. But we're in good shape. We're in the second week of class, and most of you finished Chapter 1 lab, so we're good there. But go ahead. Next week we'll pick up at 2131, and we'll talk about the different modes of operation: privilege exec versus user exec mode.
Great.
Okay, I'm gonna stop the recording and